When we're talking about domains of functions, we have to figure out what values can we use and what values can we not. One of the easiest way to do this is to plug this in your calculator and press second graph and look at what your graph looks like and where there's errors in the x values. So to start off, the domain on a function is always all real numbers until you have a restriction. And the two most common restrictions are square roots and fractions. Square roots always have to be greater than or equal to 0 because we don't do problems like this unless we're using imaginary numbers, and we're not right now. We're using the real number system. Fractions, I know the denominator cannot equal 0 because it's an undefined solution. So those are the two things we're going to focus on when we go through these problems. All right, this first problem we're going to shorten up just a bit. I'm going to take the squared part out just so we can see the gist of it. I want to find the domain of this. If I was to graph it, which is what I would do to start it every single time, it's going to look something like this. So it looks like I can use all of these negative numbers until I hit this point right here. And what is that point? Algebraically, what you're going to do is you're going to take what's inside the square root, and I know it has to be greater than or equal to 0 because I don't want negative numbers. If I put in a 10 right here, I would have the square root of -6. Could I use the number 10 in my domain? No. So let's go ahead and solve this. Let's subtract 4 to the other side. So I have -x is greater than or equal to -4. Divide by -1. And when I divide by a negative, I flip my inequality. So I can write it one of two ways. Inequality notation, interval notation. And again, read your directions to see what answer is being asked for. The next problem, we see a fraction. I know the denominator cannot equal 0, so that's what I'm going to solve. X plus 2 cannot equal 0. When I solve for x, I know that x cannot be -2. That is a solution. But if it asks for interval notation or for words, I can say all real numbers, and that's the symbol for all real numbers, except x cannot be -2, which means if I was going to do interval notation, I go -infinity to 2, but I don't include 2. Then I start again at 2, but I don't include it to infinity. Let's take a look at one more problem. Now, I have a denominator, so I know at this point this cannot equal 0. But I also have a square root, which means this has to be greater than or equal to 0. So here's how I'm going to set this up. I know that x minus 10 has to be greater than or equal to 0, but since it cannot equal 0, I'm going to say x minus 10 is only greater than 0 and not use that symbol. So then when I add 10 to both sides, my solution has to be x is greater than 10 or from 10 to infinity. And when you graph that, what you're going to see on your table of values, 10 will have a number, 11 will have a number, all of these will have an error above them.